Hello and welcome to this video. In this video, we are going to look at upper and lower bounds. What are the upper and lower bounds? Bounds are the smallest and largest number a rounded number can lie between. For example, consider the number 10, which is a rounded value of the number, let's say x. So x rounded to 10. Let's mark this x in the number line. If we draw a number line and put 10 in the middle, and if this is rounded to the nearest 10, then below is 0 and above is 20. Okay. The lower bound is exactly halfway between this 0 and 10, which is 5. And similarly, the upper bound is exactly the halfway between 10 and 20, which is 15. So x lies between 5 and 15. If x is 5, then it will be rounded up to 10. Whereas if x is 15, it will be rounded up to 20. So it is not included. So we are going to draw a circle here. This is included. 5 is included. So the circle is shaded. And this is open. Join this. Okay. This is our lower bound and this is our upper bound. LB, lower bound less than or equal to x less than upper bound. Is the inequality used here. So for any number, lower bound less than or equal to x less than upper bound. Note that lower bound is included in the range of values x could have taken, but the upper bound is not. So how to find the upper and lower bound for any number? Lower bound is take off of the degree of accuracy. That is degree of accuracy divided by 2. And similarly, upper bound is add of the degree of the accuracy. That is, for example, 20. Let's consider the number 20, which is rounded to the nearest 10. Okay, of the degree of accuracy is 10 divided by 2, which is 5. So lower bound is 20 minus 5 and upper bound is 20 plus 5. This is 15 and this is 25. So lower bound is 15 less than or equal to 20 less than 25. This is the error interval for this. Let's solve some of the upper and lower bound questions. The first question is the length L kilometer of a race is 1569 kilometer. Correct to the nearest kilometer. Complete this statement about the value of L. The degree of accuracy is correct to the nearest kilometer. So 1 kilometer. 1 divided by 2 is 0.5. So the upper bound and lower bounds are, lower bound is 1569 minus 0.5 and upper bound is 1569 plus 0.5, and this is 1508.5, 1569.5. So first we need to write the lower bound. So 1568.5 less than or equal to L less than 1569.5. The next question is, the length L meters of a piece of rope is 30.7 meter. Correct to 1 decimal place. Complete this statement about the value of L. Correct to 1 decimal place. So 0.1 divided by 2 is 0.05. So lower bound is 30.7 minus 0.05 and upper bound is 30.7 plus 0.05. This is 30.65 and this is 30.75. Lower bound is 30.65 and upper bound is 30.75. Similarly, you can try this question. Try, the mass of an aircraft m tons is 473 tons. Correct to the nearest ton. So 1 ton. So 1 divided by 2 is 0.5. Complete this statement about the value of m. So add and subtract 0.5. Try this question and share your answer in the comment section. Fourth question is finding upper or lower bound value of a calculation. For example, suppose if you are getting a question to find the perimeter of a triangle, you will be adding all the 3 sides to get the perimeter. So if the question is find the upper bound of the perimeter, then you are supposed to add all the upper bound of the 3 sides of the triangles. Okay. So if the calculation involves addition, then to get upper bound value, we need to take upper bound of A plus upper bound of B. Okay. You'll get the result as a upper bound. Suppose if it requires to find the lower bound, then you need to take the lower bound value of the A and B. If the calculation involves subtraction, that is A minus B, to get the upper bound value, that is the difference between A and B, should be high to get the biggest difference. So we have the information upper bound of A and lower bound of A, upper bound of B and lower bound of B. By using these 4 values, okay, if you take upper bound of A and lower bound of B, this will give the biggest difference between A and B. If you want the lowest difference between A and B, that is the lower bound, to get lower bound, take lower bound of A and the upper bound of B. Next, finding the upper or lower bounds for the calculation which involves multiplication. For example, if area is equal to length times width. To get a more area, that is to get the upper bound value for area, both length and width must be high. Okay, you have to take the upper bound value for length and width. To get the lower bound value, take the lower bound of length and lower bound of width. Okay, next the calculation which involves the division. For example, consider the calculating the speed which is equal to distance over time. Find the upper bound value for speed. You have to take upper bound value for the distance, and you have to take the lower bound for time. Whenever you get a fraction question like this, to get the upper bound of the fraction, take the biggest number as the numerator and smallest in the denominator. Okay. To get the lower bound value for speed, take the upper bound of time. Okay. So upper bound of speed. To get upper bound distance, we have to take upper bound, and time also we have to take inverse, so lower bound we have to take. To get the lower bound of speed for distance, take the lower bound value, and for time take higher bound value, that is upper bound value. The lengths of the sides of a triangle are 11.4 centimeter, 14.8 centimeter, 15.7 centimeter, all correct to one decimal place. Calculate the upper bound of the perimeter of the triangle. Perimeter of the triangle is nothing but adding all the three sides of the triangle. Okay. And to get the upper bound of the perimeter of the triangle, you need to add the upper bound values of each and every side value of the triangle. Okay. So this is corrected to one decimal place, that is 0.1. Divide by 2 is 0.05. Okay. So we need upper bound values only. So for 11.4, the upper bound value will be 11.4 plus 0.05. For 14.8, upper bound value is 0.05. 14.8 plus 0.05. And for 15.7, upper bound value is 15.7 plus 0.05. So this is 14.45, 14.85 and 15.75. Now to find the upper bound of perimeter, add all the three values. 11.45 plus 14.85 plus 15.75. which is equal to 5, 0, 42, 42.05. The next question is, the formula S equal to 1 over 2 AT square is used to calculate the distance S traveled by a bicycle. When A is 3 and T is 10, each correct to nearest integer. Calculate the lower bound of the distance S. So each corrected to the nearest integer. That means 1 divided by 2 is 0.5. So what is the A value? 3 plus or minus 0.5. And T is 10 plus or minus 0.5. And S is equal to 1 over 2 AT square. We require the lower bound of S. So to calculate the lower bound of S, we have to take lower bound of A because directly proportional multiplied by lower bound of T square. So we need to take a lower bound of T. Okay. Multiplying two lower bound value will give a lower bound value. So 1 over 2. What is the lower bound of A? Which is 3 minus 0.5. Okay. So ALB lower bound is 3 minus 0.5, which is 2.5. And T lower bound is 10 minus 0.5, which is 9.5. So of multiplied by 2.5 multiplied by 9.5 square, which is equal to 112.8125. Next, try this question. The sides of a square are 15.1 centimeter. Correct to one decimal place. So zero point 0.1 is the degree of accuracy. 0.1 divided by 2 is 0.05. So you need to add and subtract 0.05. Find the upper bound of the area of the square. Area of the square is side times side. So multiplication here. So if you multiply two upper bound number, the result will be a upper bound. Okay. So you need to take two upper bound values of the side of the square. Okay. Try this question and share your answer in the comment section. The next question is, a bus travels 440 km. Correct to the nearest 10 km. The time taken to complete the journey is 6 hours. Correct to the nearest half hour. Calculate the lower bound of the speed of the bus. So we know the formula to calculate the speed of the bus. Speed is distance traveled divided by time taken. We require a lower bound of speed. So speed and distance are directly proportional. So we will take the lower bound of distance. Okay. Whereas for a time, we will take the upper bound. If we take upper bound in the denominator, we will get a lower bound value for the speed. So the bus travels 440 kilometer, correct to the nearest 10 kilometer. The degree of accuracy is 10 here, kilometer. So 10 divided by 2 is 5. So the error interval for 440 is 440 minus 5, which is 435, less than or equal to the distance value, less than 440 plus 5. So 445. And for the time, it is corrected to the nearest half an hour. So half an hour, let's take it as 0.5 divided by 2, which is 0.25. So 6 hours minus 0.25. So 5.75. Less than or equal to time, less than 6 plus 0.25. So 6.25. So LB of speed is, we have to take the lower bound for distance. So this is the lower bound value. And for time, we need to take the upper bound value. So 435 divided by 6.25. So you get 69.6. So this is the speed of the bus, lower bound of the speed of the bus. The next question is, Neha has a piece of ribbon of length 23 centimeter, correct to the nearest centimeter. For this ribbon, she cuts off a piece with length 87 mm, correct to the nearest mm. Work out the lower bound and upper bound for the length of the remaining ribbon. Give your answer in centimeter. So here the length of the ribbon is 23 centimeter. Corrected to the nearest centimeter, that is 1 divided by 2 is 0.5. So 23 minus 0.5 is 22.5, less than or equal to the length, less than 23 plus 0.5, which is 23.5. And the cutoff piece is 87 mm. And correct to the nearest mm. So 1 divided by 2 is 0.5. So 87 minus 0.5 is 86.5, less than or equal to the cutoff piece value, less than 87 plus 0.5, so which is 87.5. So here the length of the ribbon is in centimeter, whereas this is in millimeter. Okay, let's convert this also in a centimeter. So for that, we are going to divide the inequality by 10. So we get 8.65, less than or equal to cut, less than 8.75. So now the cut value is in centimeter. Okay. So now both the values are in centimeter. And we need to do a subtraction here to find the remaining ribbon. Okay. Let's consider this number A and B. if you want to get the lower bound value, so for A we need to take lower bound, and for B we need to take the upper bound. So we'll get a lower bound value as the result. Suppose if you want to get the upper bound, for A we need to take a upper bound value, and for B we need to take a lower bound value. Okay, so this you have to remember. So lower bound of remaining ribbon is the original length lower bound value is 22.5 minus upper bound of the cutoff piece, which is 87.5. Okay, not 87.5, we need to take this 8.75, which is equal to 13.75. Upper bound of remaining ribbon is, to calculate the upper bound, we have to take the upper bound of the ribbon. So the upper bound value is 23.5 minus the cutoff piece value. We have to take the lower bound value, which is 8.65, which gives 14.85. So this is the upper bound value and 13.75 is the lower bound value. Try this question. The sides of an isosceles triangle are measured correcting to the nearest millimeter. One side has a length of 8.2 centimeter and another has a length of 9.4 centimeter. Find the largest possible value of the perimeter of this triangle. Okay. Try to do this question and share your answer in the comment section. I hope you found this video useful. Check out the video on upper and lower bound questions from the recent past paper, and check out the other crash course also from the description box.